This will be the discussion and explanation of the 5-1 quiz. So hopefully you've gotten yourself familiar with the rules of exponents. So in this situation, the 2x to the fourth is all taken to the sixth power. So that means the 2 will be taken to the sixth power as well as the x to the fourth. Every factor inside the parentheses will be taken to the sixth power. So 2 to the sixth, x to the 4 times 6 would be 64 x to the 24th power. For number 2, these parentheses are not necessary. You have one term here, one term here, and each term has 1, 2, 3, 4 products, 4 factors, 1, 2, 3, 4 factors. So there's no addition or subtraction going on within. It's just one term and one term, so the parentheses are not going to be necessary, and there's also not anything squared or cubed at the top of that, either one of those parentheses. There's not a coefficient out in front of either one of the parentheses, so they're really not necessary. But we have to write it correctly when we drop them. So 4x squared, y to the fifth, z to the negative fourth, and I'm just going to make it all multiplication because it is, times negative 5 times x times y to the negative third times z to the negative 1 power. So, okay, so once we get everything all broken up, because this is all multiplication, then we look at our common factors. So like we have our 4 and our negative 5, those are of the same type, so they can be kind of put together. 4 times negative 5, just like it always was, would be a negative 20. Then you have the x squareds, or the x's. You have an x squared and an x to the first, so that would become x to the third. So those are taken care of. Those are taken care of. You look at your y's. You have y to the fifth, y to the negative third. So 5 minus 3 would be y squared. And then we have z to the negative fourth and z to the negative first, which will become z to the negative fifth. But our rules are that we're not allowed to leave it with a negative exponent. So all of this is okay, but the z to the negative fifth needs to be taken to the denominator and made into z to the positive 5. Right, so in number 3 we have a fraction. So again, we kind of need to look at all of the factors that are of the same type and try to make those simplify each other. So these are of the same type, the x's are of the same type, the y's are of the same type, and so all the ones of the same type can simplify each other. But the 12 and the negative 9 simplify each other the old way. Like 12 over negative 9, both of them are divisible by 3, so that's just 4 over 3. And you can put the negative on, and you can leave it on the 3 is fine, or you can put it out front, it doesn't really matter. And then on the x's, we have x to the 8th on top, and x to the first on bottom. So since there's more on top, we'll do x to the 8 minus 1, which would be the 7th. Because basically this one right here is going to cancel off one of those 8. On the y's, we have 6 on top and 4 on bottom. So same thing, we're going to have a leftover on top, 6 minus 4, which will be 2. Because basically all 4 of these canceled out with 4 of those 6. there was 2 left. And so we're done. We don't have any negative exponents on the bottom. This negative in front of the 3 can be put here. That's probably the best way to write it. But if you left it on the negative 3, it wouldn't be wrong. It would still basically be simplified. And then on number 4, kind of the same thing. We need our constants, our factors, or coefficients to interact. But 27 and 16 don't have anything in common. They can't reduce like the 12 and 9 did. 27 is only divisible by 9 and 3. So 16 is only divisible by 4 and 8 and 2. So nothing in common. So they are not going to reduce. So they are going to actually stay as 27 over 16. We can pull the negative sign out front. But this negative sign actually is going to do something. So if we back up a second and look at this as negative 27 times x to the 3rd times, and then when you have a negative sign in here on a variable, you can treat that as a negative 1 times an x to the 7th. And we don't have anything up here to worry about, so that the parentheses there aren't doing anything more than a dot or just putting it back to back. They kind of help because of the negative sign. Because if it didn't have a parenthesis here, it would kind of look like x to the 3rd minus x to the 7th, but it's not. So they wanted to make sure you knew that this was multiplication of x to the 3rd times negative x to the 7th. And so that's kind of where they put the parenthesis there. But when you break it apart, this would mean the same thing. And then on the bottom, we have the 16 and the x to the 4th. So the x's, well, let's take care of the negative 1. The negative 1 times the negative 27 is going to cancel off the negatives. So it's just going to be a positive 27 over the 16. Then the x to the 3rd and the x to the 7th on top will make x to the 10th, and we still have an x to the 4th on the bottom. So since we still have some x's on both the top and the bottom, we need to get those simplified. So this, since there's more on top, we'll say it's x minus 4, which would be 6. Or 10 minus 4, which would be 6. So that would be simplified. All right, see you later. All right, so on number 5, we actually have a negative sign out front, but that's but since there's only one term inside, all that's really going to do is multiply negative 1 times that. So it'd just be negative 4 times x to the negative 3rd times z to the negative 5th. You don't want to put a negative on each one of those because they're not separate terms. They're just separate factors. So it's almost like doing this, negative 1 times that. And then, but over here we have a squared on the outside of the parentheses. So that means that before we take the parentheses off, we're going to have to make that 8 squared and x squared. So then we start to simplify everything. We have the negative 1 times the 4 times the 8 squared. 8 squared is 64. I'll go ahead and evaluate that. So 4 times 64 is 256. So 256 times negative 1, so it'd be a negative 256 on top. All right, that takes care of the coefficients. All right, then we have an x to the negative 3rd and an x squared. Now they're both on top, they're not in the bottom of the fraction. We add them together and you get x to the negative 1. Z to the negative 5. Okay, but we're not allowed to have negative exponents, so we need to make this into a fraction so that we can put the x to the 1st in the denominator and the z to the 5th in the denominator, and leave the negative 256 on top. And that's done. On number 6, again, there's no exponents above these parentheses, but there is here. So we're going to have to address that. But since there's no exponents on the parentheses, we can just drop the parentheses and everything is multiplication. And then on bottom, we need to address this. So that's a power to a power. That'd be x to the negative 12th, y to the negative 2. Then let's start to simplify our common factors. Our common factors, we've got 3, not necessarily common factors, but factors of the same type. 3 times 5 would make a 15. Those will go away, they're on top. Then we have x to the negative 2 and x to the first, and then x to the negative 12 on bottom. Now if we make everything positive right now, it might be a little bit easier to see. Let's go ahead and make everything positive. Even though we can do it, it just might be easier to see the other way. So we're going to leave the y to the third where it's at because it's positive. We're going to leave this x where it's at because it's positive. This y to the negative 8, we're going to put downstairs with y to the 8th. This x to the negative 2, we're going to put downstairs as x to the 2. And these two are going to go up. So this would be x to the positive 12 and y to the positive 2. I kind of got myself all crowded up. But, so in the top we have a y squared and a y to the third now, so that becomes y to the 5th. So 15 y to the 5th. That takes care of that. That takes care of that. That's taken care of. X to the 12th and x to the first makes x to the 13th. Okay, so those are taken care of. And in the bottom I have an x squared and a y to the 8th. All right, now the top and the bottom can start to interact, and it's a little bit easier to see. The y to the 5th and the y to the 8th, since I have more in the denominator, all of these will go away, and 5 of those 8 will go away. So the y, 8 minus 5 would be y to the third on bottom. As far as the x's go, we have 13 x's in the top and 2 in the bottom. So that means all of these will go away, and 2 of those 13 will go away. The x to the 11th, and the 15 is still unaffected. So that should be your answer. Right, number 7 is a little bit different because the parentheses are not back to back anymore. They are separated by a plus sign. And we have addition here and subtraction here. So this is different than the other problems because before it was all multiplication and all multiplication, and it was multiplication here. But this is totally different. You have 2 terms, 1, 2, in the first parenthesis, and you have 2 more terms in the second parenthesis. Now since this is a plus, I don't have to distribute anything. It's just a plus 1. It's not going to affect anything. So basically, I can again drop the parentheses off and then collect like terms. This is totally different than what we've been doing. Collecting like terms is not the same as simplifying all that multiplication we were doing. 3x squared plus 8x squared, this is Algebra 1 stuff. This is not anything new. That's just 11x squareds. And then 1 minus 8 is a negative 7. This is a different type of problem. That's the old, that's not a new type of problem. Number 8, on the other hand, does not have an addition or subtraction in between the parentheses. So these 2 parentheses are multiplied together, but it does have multiple terms. There's 2 terms here, and there's 3 terms there. So what we have to do is we have to basically do a souped up FOIL.
What?
FOIL. So since we have 2 terms here and 3 terms here, we have to take the first term, we have to look at every combination of multiplication between the terms.
I remember this crap.
And that would become x to the third. From here, this would be x times x squared is x to the third. This would become negative 2x squared y. And the last one would become
Plus 4x.
x y squared, right. Then we go and we distribute the 2y. That becomes 2y, or x squared y, I'll put the x's first. 2x squared y, alphabetical. And then this would become negative 4 x y squared. And that would become
Plus
8
y cubed.
y cubed. Very good. Then we collect our like terms.
I remember this.
But it just so happens, if we look for all the ones that are identical, do we have any other x cubes anywhere? No. So it just, that one doesn't change. Let's look for all the x squared y's. Here's another one. They're both the same but opposite signs. So they cancel out. We have 0 x squared y's left.
Then the 4x y squared cancels out too, and all you're left with is x cubed plus 8y cubed.
Same thing happens with the 4x y squareds. They are the same but opposite signs, so they zero out. So all you're left with is the 8y cubed. All right, number 9, we're trying to find the volume of the box. Volume is equal to the area of the base times the height, or it's length times width times height. But length times width is the area of the base. The base is a rectangle, area of a rectangle is length times width. So they don't give us the length and width, they go ahead and give us the result of length times width. They give us the area of the base. And then they give us the height. So we need to multiply the area of the base times the height. Now you can put the x plus y here, or you can put it out front so that it looks a little bit more similar to problem number 8. So we're going to do that souped up FOIL here. Distribute the first term to all 3 of the terms in the second parenthesis. We get x cubed minus 3x squared y plus 2x y squared. And we'll distribute the y. That becomes x squared y. Just 1x squared y. That becomes negative 3xy squared. And that becomes 2y to the third. And now when we combine our like terms, I don't have any other x cubes. I have 2 terms that are x squared y type, negative 3x squared y, and basically a 1 x squared y. That becomes a negative 2 x squared y. I'm done with those. Now let's go to the next term, which is of type xy squared. We have another type xy squared right there. And we put those together. 2 minus 3 is negative 1. So negative 1 xy squared. I don't need to write the 1. And then all I have left is the y to the third, which I have no others of that type. So he's going to stay as he is. Now all 4 terms are different. They're unlike, so I can't combine them any farther. Nothing cancels out. We're left with a 4-term answer.